Like a criminal undercover, going pop like trouble, breaking into your heart like that. I should've stayed.
Alright, what is metals? Generally, metal is a solid material which is typically hard, shiny, have high density, ductile, with good thermal and electrical conductivity. For example, iron, gold, silver, and aluminium, and alloys such as steel. Next, metallic materials. So it have two types, which is non-ferrous metals and alloy, and ferrous metals and alloys. The differences is non-ferrous metals and alloys do not contain iron, while ferrous metals and alloy contain large percentage of iron. Some common ferrous metals include cast iron and rough iron.
Let's move on to the advantages of ferrous alloys. First, ferrous materials are produced in larger quantities than any other metallic materials, as iron ores exist in abundant quantities. Next, economical extraction, refining, and fabrication techniques are available to produce the alloys. The alloys also may be tailored to have a wide range of properties. Then, high strength-weight ratio compared to non-ferrous. This is because they consist of iron and alloyed with carbon, which increase their strength. Ferrous metal also very magnetic, which is useful for large electric equipment and motors. Last, it is recyclable and environmental friendly. The disadvantages of ferrous alloys includes they are susceptible to corrosion, which means they corrode easily. They also have relatively high density, means they are heavier compared to non-ferrous and have relatively low electrical conductivities. What is cast iron? Cast iron is produced by smelting the iron-carbon alloys, then pour it into a mold and allow it to cool. It is an alloy made from iron, silicon, and carbon with a carbon content more than 2%. This iron is great for the environment as it can be recycled. Cast iron can be strong in compression and was used in building the construction. However, it can be weak in tension and bending. Means it cannot be bent, stretched, or put into shape as it will fracture before it bends or distorts. Cast iron has poor weldability and ductility as it is considered to be relatively brittle with crystalline structure. Cast iron does not rust due to high carbon contents. Next, wrought iron. Wrought iron is an iron with very low carbon content, and during the manufacturing process, the iron is removed from heat and worked with hammer while still hot to get it into its intended form. It can be heated and reheated and put into various shapes, meaning it is highly malleable and more ductile than the cast iron. It is also tough and easily welded. It gets stronger the more it's worked. Wrought iron is more expensive than the cast iron due to its manufacturing process. And for the additional information, modern wrought iron are made steel which contain 0.15 to 0.3% carbon. Cast iron are widely used in making pipes and automotive parts and commonly found in kitchenware such as pans and utensils, whereas wrought iron used in decorative items such as gates, railings, and fences.
For the advantages, non-ferrous metals and alloys, it has high corrosion resistance, so non-ferrous metals do not rust or oxidize. Non-ferrous metals are often low in weight. For the disadvantages, non-ferrous metals are often cost more than ferrous metals, top price depending on the metal. Since the cost of non-ferrous metal is higher than ferrous metal, industry or companies that use non-ferrous metal for application are at disadvantages. Non-ferrous metals and alloys has lower tensile strength. Having lower tensile strength means a material is more likely to break without reinforcement.
Thermal processing of metal can be used to control the microstructural and mechanical properties of the metal alloy. Annealing is a heat treatment process in which a material is heated above its recrystallization temperature for a set amount of time before cooling the room temperature at relatively slow rate. This process intends to alter the microstructure of a material to change its mechanical or electrical properties. This is an example video for annealing process. We can see here the metal piece being heated using a torch. The torch was moved slowly across the metal so that the metal piece will be heated evenly. The larger the size of the metal piece, the longer it takes for it to be heated evenly. The metal piece is ready when dull red glue that is consistent across the entire piece is formed. Then, let the metal piece cool. This annealing process will help improve the ductility of the metal and reduce the hardness to avoid distortion and cracking, hence indirectly make it more workable.
Last part for metals is quenching. What is quenching? It is a heat treatment method that quickly returns metal to room temperature after it is heated above its upper critical temperature. The quenching process stops the cooling process from altering the metal's microstructure. In another word, quenching is a rapid cooling, as by immersion in oil or water, of a metal object from the high temperature at which it has been shaped to preserve mechanical qualities associated with a crystalline structure.
Ceramic are inorganic and non-metallic group of material that are generally made by taking mixture of clay, feldspar, powder, water, and shaping them into a desired form. Once the ceramic has been shaped, it is fired in a high-temperature oven known as a kiln. Often, ceramic are covered in a decorative waterproof paint-like substance known as glaze. Ceramic consists of ionic or covalent bond that responsible for many unique properties such as extremely durable, high melting point, and good electrical insulator. It also have undesirable properties which is brittle because they are loaded with irregular distributed pores. Some ceramic, like brick, have a larger pore. The larger the pore, the easier ceramic to break. If you ever broken a ceramic vase or some such, the break probably originated at the pores. Due to the molecular structure, it is not resistant to shattering. If a ceramic case falls into a hard surface from a few feet or more, there is a good chance that it may shatter. Ceramic can be classified into 6 categories. The first one is traditional ceramic. It is usually used as a houseware or construction material. For the example is hydrated aluminum silicate, silica, and potash. Advanced ceramic. It is usually used in a biomaterial and engineering industry. For example is oxide, carbide, zirconia, and composite. The application of advanced ceramic is in aerospace industry. The reason they are using ceramic for some part of aircraft bodies such as turbine because ceramic are lighter and it also can help to faster the speed of military jet. It also applies to dental appliances such as crown and veneer. Glasses is inorganic solid material that are usually transparent or translucent as well as hard, brittle, and impervious to the natural element. That means it is not resistant to the natural elements such as metal and rock. There are non-crystalline silicate containing other oxide such as calcium oxide, natrium oxide, potassium oxide, and aluminum oxide which influence the glass properties. For the example is kitchen appliances such as a microwave, a glass stove, and glass. Clay is a soft, loose, earthy material containing particles with a grain size less than 4 micrometers. Clay is one of the most widely used ceramic raw material. China clay, also known as kaolin, is one of the most important substances to produce whiteware ceramic. The whiteware ceramic become white color after the high temperature firing. The application of clay is tableware, vase, and art decorations. Refractory ceramic is inorganic non-metallic material which can stand with higher temperature without undergoing chemical changes. When exposed to high temperature, they do not lose their strength and do not change in any form. For the example is silica and alumina system. The application of refractory ceramic is fire clay refractory that used in metal working industry and silica brick. The last category is abrasive ceramic. Abrasives are used to wear, grind, or cut off other material. There are two types of abrasive, which is natural abrasive such as diamond that relatively expensive. Another one is synthetic abrasive that are usually used in the form of grinding wheel, sandpaper, honing stone, polish, and cut-off wheel.
Moving on to the fabrication of the ceramic, where it takes place through powder metallurgy, which is a metal forming process performed by heating compacted metal powders to just below their melting points. The basic steps processing are first, raw material preparation, where any material converted into powder through various processes such as atomization, grinding, and more. Next is forming and shaping, where two or more material powder will be mixed to produce high-strength alloy material. Then, material treatment by drying and frying, which is sintering, that we'll be explaining later. Lastly, final forming, where the sintered product can be used or not. In thermal treatment of ceramics, first there is a drying where the water is removed and carried out at or below 100 degrees Celsius. In this process, the layers, size, and spacing will be decreased. Then, firing will occur when the temperature is raised to 900 to 1400 degrees Celsius. What is sintering? Sintering is the process which small particles are bonded together by solid-state division at a very high temperature but below the melting points of the compound. In the mechanism of sintering, first sintering will occur during firing of a piece that has been powdered pressure. Next, during the initial sintering stage, neck form along the contact regions between adjacent particles. In addition, a grain boundary forms within interstice between particles become pore. Lastly, as sintering progresses, the pore becomes smaller and more spherical in shape. Some ceramic products, such as porcelain, contain a glass face. When ceramic is fired, a process known as vitrification takes place, whereby the glass face will liquefy and fill the open spaces between particles. As the body cools down, the glass solidifies and acts to bond the unmelted particles together.
So, the next slide, we will go through the last part of this topic, which is polymer. Polymer is a large molecule made up of chains or rings of linked repeating subunits, which are called monomers. So, most polymers are hydrocarbon that made up of hydrogen and carbon. As an example, you can see from the picture in slide, polyvinyl chloride, which is PVC, and also polypropylene, which is PP. Polymers usually have very low density, low melting point, low elastic modulus, and ductile and also brittle type. Family of polymers consists of plastics and elastomers. Elastomers, also known as rubber, while plastics are organic or processed materials that can be made into objects or filaments. Plastic can be divided into two, which are thermoplastics and also thermosetting plastic. Thermoplastics can be reheated and formed into new materials in several times without significant change to materials' properties. Heat is required by this kind of polymers to be shaped and after cooling retain the shape that is formed. And usually, thermoplastic have very long chain and hydrocarbon and covalently bonded. In engineering side of thermoplastics, it has low density and low tensile strength. It also high temperature insulation, which is an insulating substance that protects from extremely high temperature and is used in manufacturing, cars, electrical appliances, and so on. It also known as good corrosion resistance. Next, we move to thermosetting plastic. It's opposite with thermoplastic, which cannot be remelted or reformed by reheating. Thermosetting plastic is a polymer materials that are formed into permanent shape, can be cured or set, and some do so even at room temperature by certain chemical reactions. In general, polymer is made up of chain of carbon networking with covalently bonded nitrogen, sulfur, or the other atoms in structure. In engineering side of thermosetting plastic, it also have many uses because of high thermal stability, high rigidity, resistance to creep and deformation under load, lightweight, high electrical, and also thermal insulating properties. So from this slide, you can see some of the examples of thermosetting plastic, which are epoxy resin, polyester resin, melamine formaldehyde, and lastly is urea formaldehyde. Next is comparison between thermoplastics and thermosetting plastics. Thermoplastics has little cross-linking, low density, low rigidity, low tensile strength, soften with heating, low thermal stability, has ability to recycle, remove or reform upon heating. As examples are polyethylene, PVC, polypropylene, polycarbonate, and also polystyrene. While for thermosets, it is opposite with thermoplastic, which has a large cross-linking and it is not reversible. It's hard and brittle because chain cannot rotate or slide. It has high tensile strength, do not soften with heating, degrades rather than melted. High thermal stability, high rigidity, high dimensional stability. Cannot be recycled and removed on heating. As examples are vulcanized rubber, epoxies, polyester resins, and phenolic resins. So the last slide is about elastomers and vulcanization. Elastomers or rubbers is a natural or synthetic polymers whose dimensions can be greatly changed when stressed and that return to its original dimensions when the deforming stress is removed. While vulcanization is a process by which polymer molecules are joined together by cross-linking into larger molecules. So, heating rubber with sulfur leads to restrictions of the polymer chain movements, thus makes the polymer become harder and stronger and also less elastic.